at this. What we're going to do in this section is we're going to look at double angles, triple angles, half angles, quadruple angles, all that kind of stuff. And I want to show you what's going on graphically. So if you have just the sine curve, and remember for our purposes, we are only looking from 0 to 2 pi or 0 to 360. So we're only looking from here to here. Now this is your sine curve, okay? This is your basic sine curve. Look what happens when I double it. So now red is the basic sine curve, okay? Your red curve is your basic sine curve, but then the green curve is sine 2x. Basically what that's saying is from 0 to 2 pi, I need to fit 2 sine curves in there. Watch. 2 sine curves. There's 1 and there's 2. So I need to fit 2 sine curves in there. Well, if on basic sine I'm looking at where x is 1/2, okay? Look at your red curve. X is 1/2. It's a hit here and here, and that was it. But when I fit 2 sine curves in there, look at what happens. On the green, we get 1, 2, 3, 4 times. So when you double an angle, when you double the sine curve, you should expect more answers. You have more opportunities to hit what you're trying to hit. Look what happens when I quadruple. Now I need 4 sine curves in there. 4 sine curves from 0 to 2 pi. There's 1, 2, 3, 4. So now if I'm looking at 1/2, how many times do I hit? 1, 2, 3, 4, 5, 6, 7, 8, 8. So you quadruple your opportunity to hit. So what do you think is going to happen when I look at a half angle? Now look at the green. I hit once and I hit twice. Did you see what it does? I only want half of the sine curve from 0 to 2 pi. I only want half of the sine curve. Look at the cosine curve. Here's your cosine curve. The red is your basic cosine curve. And if I was at 1/2, I would hit 1, 2. But if I only want half of the cosine curve from 0 to 2 pi and I was at 1/2, it only hit 1 time. So you half your opportunities of hitting your mark. Okay? So if you double your curves, then you double the opportunity of hitting the marks, whereas you half your curve, you're halving your opportunity. Now, is that always going to happen? Not necessarily. So, what happens is this. You're going to have to use something called U substitution. For those of you who are going into calculus, you need to remember U substitution. Okay? Because we're going to use it a lot, a whole lot. So, if I look at cosine 2x is equal to negative 1/2. Cosine 2x is equal to negative 1/2. What I'm going to do is I'm going to look at the basic cosine curve. What I'm going to do is I'm going to look at cosine of what angle is equal to negative 1/2. So basically what I've done is I've let 2x equal u. Because what I want to do is I want to look at the nature of just the basic cosine curve at 1/2. From 0 to 2 pi. From 0 to 2 pi. So what I'm going to do is I'm going to figure out what u is. So I'm going to go down through there and I'm going to figure out where is cosine negative 1/2. Well, it's negative 1/2 at 2 pi over 3. And it's also negative 1/2 at 4 pi over 3. But I don't want the cosine curve. This is just my starting point. This just gives me an idea of where to start. So what I want to do is I want to put my 2x back in there for you. So I'm going to say 2x is equal to 2 pi over 3 over the interval of 2 pi. But I want to know how many times we're going to hit if we double it. And that's what k is. K is going to tell me everywhere I'm going to hit if I double the curve. Okay? So basically what I did is I said, instead of saying u is equal to 2 pi over 3, what is u equal to? What did I substitute u for? 2x. So there's 2x. So instead of u equals 2 pi over 3, I'm going to say 2x is equal to 2 pi over 3. Over the course of 2 pi, I want to know how many times is it going to hit, and that's what k is going to be. But I'm not solving for 2x. What am I solving for? Anytime you solve an equation, are you solving for 2x or are you solving for x? So anytime you solve an equation, you want to solve for x. Can you tell me how I'm going to get x by itself? Divide everything by 2. Well, to me, it's easier to say 1/2. Dividing by 2 and multiplying by 1/2, you agree with me that that's the same thing? Dividing by 2 and multiplying by 1/2 is the same thing. So what you're going to do is you're going to multiply every single term by this 1/2. Now get your calculators out because you're going to need it, especially if you're not fraction friendly. If you're not fraction friendly, you're definitely going to need a calculator. So 1/2 times 2x, that's going to give you x. That's what I need. Is equal to, what's 1/2 times 2/3? Forget about the pi, okay? It's just a constant. What's 1/2 times 2/3? And then 1/3 times pi is going to be pi over 3 plus 1/2 times 2 pi k. Basically 1/2 times 2. 1/2 times 2, the 2's cancel out, right? So you're just going to get pi k. Now, what is that k? K is going to tell me where that cosine 2x is going to hit. So let's pretend that k is equal to 0. If k is equal to 0, what is x going to be equal to? Do some math. If k is equal to 0, what happens here? It goes away, and so x is equal to what? Pi over 3. So I know that cosine 2x is going to hit at pi over 3. That's my first opportunity. K equals 0 is your first opportunity to hit. Okay? K is equal to 1. That's going to be your next opportunity to hit. If k is equal to 1, do some math. 1 times pi is going to be pi, and pi over 3 plus pi. And this is where it gets kind of crazy. Pi over 3 plus pi. In order to add fractions, what do you have to have? Common denominator. Common denominator is going to be what? 3. And there's understood to be a 1 right there, right? Pi is a constant, but it's a variable as well. I know this here. So this is going to be 4 pi over 3. Pi is a letter, but we know what pi stands for. It's not an unknown, but it is a letter. Okay. So, why did I put pi over 2? That should be pi over 3. And y'all didn't catch that. So, when we say 4 pi over 3. Okay. What happens if k is equal to 2? If k is equal to 2, what do I get? If k is equal to 2, what do I get here? I get 2 pi plus pi over 3. Does that our domain? Yes, so I don't even have to worry about it. Anytime you hit 2 pi or above, you're done. So you don't even have to worry about this. Okay, that's only half of your answers. Because remember what happens if just basic cosine curve hits -1/2 twice, and I double that cosine. I double the amount of cosines between 0 and 2 pi. How many times should I expect to get? You should expect to get 4. So this is only half of your solutions. It hits at pi over 3, and it hits at 4 pi over 3. Where's the other 2 going to come from? You're going to do the exact same thing. Instead of u equaling 2 pi over 3, we're going to say u equals 4 pi over 3. But not u. What are we going to use? 2x. So we're going to say 2x is equal to 4 pi over 3 over the interval of 2 pi. And how many hits am I going to get? That's what k is. But again, I'm not solving for 2x, I'm solving for x, so I've got to multiply by 1/2. So x is equal to what? 2 pi over 3 plus pi, okay? Okay, so if k is equal to 0, then x is equal to 2 pi over 3. If k is equal to 1, see if you can figure out what x is going to be equal to. Anybody have any ideas? Very good. 5 pi over 3. So what did he do? Well, go back over here. We're starting with 2 pi over 3. 2 pi over 3. I still need a common denominator, so 2 pi's plus 3 pi's is going to be 5 pi's, which will make it fast. 5 pi over 3. So how many answers do you have? You have 4. Here are 2. And here are 2. So make sure you get all 4 of these on your answer blank. Make sure you get all 4 of them on your answer blank. Questions? Now this is going to take a little bit of time to wrap your brain around. Okay? It's U substitution. But once you understand U substitution, when you use U substitution, you're just doing basics. But then you got to go back and resubstitute what you substituted U in for and get what you really mean. Okay? U just allows us to use something that we already know. Because we can just look at our chart and see where cosine is equal to -1/2. But that's not what we're interested in. U just allows us to do something basic. Then what we have to do is we have to go back and change our U out and actually find what we're looking for. Okay? So U just allows us to find a starting point. Okay, so this time we are going to have 3 sine curves from 0 to 2 pi. Okay? 3 sine curves from 0 to 2 pi. So that being the case, let's go ahead and do our U substitution. Let's go ahead and start with something that we know. Where is sine equal to 0? Where is sine equal to 0? Well, if we go down through here, sine is equal to 0 at 0. And it's also equal to 0 at pi. And it is at 2 pi again, but 2 pi and 0 are the exact same thing. So here are our 2 starting points. So let's go back and figure out what we actually want. This is just our starting point. This is something that we already know. Now let's try to figure out what we don't know, which is what happens if we shove 3 sine curves from 0 to 2 pi. This is just if we have 1 sine curve. So what we're going to do is we're going to say 3x. Instead of u equal to 0, we're going to say 3x is equal to 0 plus 2 pi k. But we don't want 3x. What do we want? We want just x, so what are we going to multiply 3 by? 1/3. So we're going to have x is equal, too many colors. X is equal to 2 pi over 3, okay? Right? Because 1/3 times 0, that's nothing. It put me to sleep. That's not good. Okay, so if k is equal to 0, what is x equal to? 0, and we already know that because no matter how many sine curves we put in here, they all start at 0. If k is equal to 1, what is x equal to? 2 pi over 3. If k is equal to 2, what is x equal to? Forget about the pi. Just multiply 2/3 times 2. What do you get? Leave it as an improper fraction. There you go. 4 pi over 3. And if k is equal to 3, what is x equal to? Are y'all just being quiet, or do you not know how to do this? 2 pi over 3 times 3. What do you get? Two pi, but is that an option? Why is that not an option? Look at your domain. Cannot be equal to 2 pi. So this one doesn't count. Okay, so now let's go back with the other one. 3x is equal to pi plus 2 pi. Okay. But we don't want 3x, we want x. So we're going to have to multiply by 1/3. So we're going to get x is equal to pi over 3 plus 2 pi over 3. Okay. Okay, so if k is equal to 0, what is x equal to? Good. If k is equal to 1, what is x equal to? Should be equal to pi. Watch this. You have pi over 3 plus 2 pi over 3 times 1, which is 2 pi over 3. So you have 1 pi over 3 plus 2 pi over 3, which is going to be 3 pi over 3, which is pi. Okay? If k is equal to 2, x is equal to, what do you think? Well, we have pi over 3 plus 2 pi over 3 times 5. Not 5, times 2. Let's try that again. So you have pi over 3 plus 4 pi over 3, which is going to be 5 pi over 3. And can you imagine what's going to happen if k is equal to 3? You're going to go outside your range, or your domain. So it's no good. Okay, so this time, how many answers do you have? 6. You have 6 answers. There's 3 of them. And there's the other 3. It's that U substitution thing. Okay, what are we doing to the sine curve? What are we doing to the sine curve? We're halving it. We only want half of the sine curve from 0 to 2 pi. We only want half of the sine curve from 0 to 2 pi. But let's go ahead and start with what we know. sine u is equal to 1. So go down through there and figure out where sine is equal to 1, and we're in degrees, so we're looking at 90 degrees. That's it. Yeah, that's it. Okay. So, instead of saying u is equal to 90 degrees, we need to say that theta over 2 is equal to 90 degrees. Plus, instead of 2 pi, because we're not in radians anymore, what's the degree equivalent to 2 pi? 360 K. But we're not looking for theta over 2. What are we looking for? We're just theta. So we need to multiply 3 by 2, right? So we're going to have theta is equal to 180 degrees plus 720 K. 720 degrees K. So you're thinking, well, we're already out of the range. Well, your first hit is going to be as K is what? 0. So if K is 0, theta is going to be what? 180, which is good. That's a good thing. But if K is equal to 1, that puts us way out of range. So that's no good. So you only get one answer here. And that should make sense because we have the sign. We have the sign curve. Okay. We need cosine by itself. So what do we need to do? Or we need cosine and its argument, okay? Look at all of this as one thing. Look at all of this as x. So if I need cosine and its argument by itself, well, how am I going to get rid of 2 radical 3? Divide. That's the same as 2 radical 3x is equal to negative 3. Well, to get x by itself, I'm going to have to divide by 2 radical 3. So if I divide everything by 2 radical 3, you're going to have cosine of theta over 2 is equal to, now this is a no-no, so you're going to have to do radical 3 over radical 3. Not to mention the fact if you look at your unit circle or your chart, you're not going to see negative 3 over 2 radical 3. So we're going to have negative 3 radical 3 over 6, which is going to be negative radical 3 over 2. Now that you will find. That you will find. So first of all, let's look and see where cosine is negative 3 radical 2. Look and see where cosine is negative radical 3 over 2. And we are in degrees, so it's 150. Negative radical 3 over 2. Is there another one? 210. And there shouldn't be another one. Again, where is cosine negative? What quadrants is cosine negative? 2 and 3. So you shouldn't look anywhere else. Cosine is negative only in 2 and 3, so you should only look in quadrants 2 and 3. Okay. But instead of u being 150, what do we want equal to 150? Yeah. We want theta over 2 equals to 150. And what is the range that we're looking at? All the way from 0 to what? 360. And we want to know where. How many hits do we get? So at our first opportunity, K is going to be, oh, no. We're not looking for theta over 2. We're looking for theta. Let's multiply 3 by 2. All right, so theta is going to be, what, 300 plus 720K? Now we can go. If K is equal to 0, theta is going to be 300. Well, if K is equal to 1, we're already in trouble, right? So is this your only answer? No. We got a 210 to go for. Instead of u equal 210, we need to say theta over 2 is equal to 210. And then we need to put our range in there, 360 degrees. And our possible hits. So if k is 0, our first possible hit, dadgummit, please get theta by itself, which is something I, for some reason or another, I'm forgetting. Alright, so we're going to get theta is equal to, what, 420 degrees? Plus 360k. So you know what? Even if k is equal to 0, theta is going to be 420, which puts us out of our range. So we do only have one opportunity, and that's at 300 degrees. That's our only opportunity to get a hit. What do you think? Okay. We want 4 sine curves. 4 sine curves from 0 to 2 pi. 4 sine curves from 0 to 2 pi. How many hits do you think we're going to possibly come up with? 8. Should possibly come up with 8. Possibly come up with 8. So let's start with our basic sine curve. Where does sine hit radical 3 over 2? And we're in radians. Pi over 3. And where else? 2 pi over 3. Sine is positive only in 1 and 2, so there's no sense in looking anywhere else. Those are our opportunities. Okay. Instead of u equals pi over 3, let's do 4x is equal to pi over 3. And then we're going to turn around and say 4x is equal to 2 pi over 3. Let's put our range in there. Our domain in there. We're going to go from 0 to 2 pi, and with our hits. So we'll do 2 pi k. But again, we're not looking for 4x, we're looking for 4, so let's fourth everything. Multiply everything by 1/4. So now we're going to have x is equal to, watch what happens to this. Instead of pi over 3, which is already kind of small, this is going to go to pi over 12. That's tiny. Plus pi over 2. Okay. And then the one on the right, it's going to go to pi over 6. Plus pi over 2. Okay. Alright, so let's find all of them. If k is 0 on the one on the left, x is equal to pi over 12. Now this is going to be some good work for you to figure out these fractions. Again, if you're not fraction friendly, grab out that calculator. If k is equal to 1, x is equal to pi over 12, 1/12, plus pi over 2, or 1/2. In other words, in your calculator, do 1/12 plus 1/2, and you want improper fractions. 1/12 plus 1/2, and you want an improper fraction. What'd you get? Which is basically 7 pi over 12. 7/12, which is going to be 7 pi over 12. Okay, so we have 2 hits. What if k is equal to 2? What if k is equal to 2? What is x going to be equal to? See if you can figure out how to do this on your calculator, unless you know how to do it in your head. Anybody? Yep, 13 pi over 12. Very good. Need to keep going. What if k is equal to 3? Good. 19 pi over 12. Just out of curiosity, what's going to happen if k is equal to 4? If k is equal to 4, you're going to get 2 pi. And then if you add another pi over 12, that automatically puts you out of your domain. So k is not going to be equal to 4. Okay, let's go to the other side. If k is equal to 0, what is x equal to? Pi over 6. That one's easy. If k is equal to 1, what is x equal to? What? I'm hearing two. The answers are the same, but one's reduced and one's not. 2 pi over 3. What if k is equal to 2? What is x equal to? Very good. Make sure you know how to do this in your calculator. I don't know who's giving me those answers, but whoever it is has got it going on. Make sure everybody else gets it going on. Alright, if k is equal to 3, whoever's giving me those answers, don't shout it out. Somebody else, tell me what it is. Do we agree or disagree? That's what I'm thinking. If k is equal to 3, you're going to have 3 pi over 2. And then you're adding that to pi over 6. So a common denominator would be 6. So that's going to be 9 pi over 6. So that's going to give you 10 pi over 6, which will reduce to 5 pi over 3. Okay, so 8 answers. 8 answers. Here's 4 of them. And here's the other 4. So again, how do you know when to stop? When you get above 2 pi over 360. That's when you're going to stop. That's how you know when to stop. Okay, remember when I told you, and again, keep an open mind on this, okay? Remember when I told you about identities? I want you to look at this problem. We haven't worked a problem like this yet. Because on the left-hand side, we have just a single angle. Do you see that? Cosine theta is just a single angle. On the right-hand side, we have a double angle. That cannot happen. That's when you know you have to use identity. You don't have a choice. You have to use identities. So what you're going to do is you're going to get your identities chart out. And we either want to turn cosine theta into a double angle, which I would think would be totally ridiculous because obviously double angles are harder to work than single angles. Or you want to turn your double angle into a single angle, which I think would be smart because those are a little bit easier. Now, unfortunately, cosine 2 theta can be turned into 1, 2, 3 different things. It can be turned into cosine square u minus sine square u, which is an option. It can be turned into 1 minus 2 sine square u, which is an option. And it can also be turned into 2 cosine square u minus 1, which is an option. All 3 of those are possible, and you'll come up with the exact same answer no matter which one you turn it into. It's just there's an easy way to do it and a hard way to do it. Take a guess as to which one would be the easiest one to use. If our problem is already in terms of cosine, why in the world would you want to throw a sign in there and mess it up? You know? So I'm thinking cosine theta minus 1 is equal to 2 cosine squared theta minus 1. Now, this is quadratic, right? This is quadratic, so you know everything has to be set equal to 0. So let's, typically we would take everything to the left, but I think I'm going to take everything to the right. Let's minus cosine theta and add 1. So now, everything goes to 0 over here. And on the right-hand side, the 1's go away, and I'm left with 2 cosine square theta minus cosine theta. You can't put those together. One's squared, one's not. But since it's a quadratic, what do we know to do? Factor out a cosine. And we've already done this. Factor out a cosine. So you're going to get 2 cosine theta minus 1. Set each one of them equal to 0. And solve. And then look at your unit circle. Look at your unit circle. Where is cosine theta equal to 0? We're in degrees. Look at your domain. Where is cosine equal to 0? You're at 90 and 270. Where is cosine equal to 1/2? You're at 60. And you are at, it's going to be in quadrant 4 somewhere, 300. So, when do you use identities? When is the biggest trigger to use identities? When you have a single angle and a non-single angle. Use those identities. Okay.